finally see again. I had a eye exam this morning to get dilated, like my first class. I didn't even look at my computer without it hurting. So that was fun, but it's getting better now. And I also got this really cool pair of sunglasses. Check this out. They roll up, slide right in here. Let's go. Good Thanksgiving. I'm sorry. Didn't we get class? That was a positive, or was the final project too annoying? Like, I'm sure most people would do to bother, but some people are like, they want to work ahead and get stuff done. Hey, that's cool. So, your time as an adult, how cool is that? Which also sucks 2 in the morning when you're doing something. Go to bed. But rolling here. Quiet. Alright, these are ridiculous. They are amazing. So, we have a couple things today to talk about. Again, we're not going to get super deep on the topic. We're going to come back to this semester if you're continuing on. So, we're only going to kind of scratch the surface of inheritance enough so that some of these other things we're going to do make some sense here. Because we'll use it when we do graphics and stuff, which is fun. And then Wednesday we'll talk about recursion. Again, just a surface level recursion. We'll go deeper on this next semester as well. The week after we've got plotting. Now, there's so much you can do with plotting here. There's a really cool library and on YouTube. There's all sorts of cool videos. Plotlib. So someone has like a whole 4-hour tutorial here. Is this the guy I saw? There's a whole playlist. Yeah, this might be it. I think I just saw this. Yeah, so 10 videos this guy did worth of Matplotlib for different types of things. And this still only scratches the surface here when we get to plotting. There's so many cool things we can do with it. So we're going to introduce it. This is how you do it. If you want to do a specific plot, here's where you go look up how you go do it, which is pretty similar. Like, here's a tool. This is how it works. Go have fun with it later. Sort of idea here. So we'll get to that. And then basic graphics is really neat. We can finally have a program that pops up a window with a place you can type and buttons you can click on instead of typing in at the console. Again, I think I promised we're not going to go more than, say, 45 minutes each of these days. You'll have a good half hour each session to work on this final project coming up with you and your partner. The lab today, we'll talk about inheritance. Lab next week, we'll just do some real quick plots. You'll have most of lab time to work on the final project. And then we aren't until Wednesday, I think, for the final exam, final project presentations. Again, the goal with that is we demonstrate step 1, where you play the game of blackjack, play a hand, hit, stand, win, lose, or draw, see what happens, right? And then you run your simulation and say, okay, let me have the computer play 100,000 times, randomly pick hit or stand 1 time. Here's the results, output. So, with, what do we say? So if there's 100,000 hands that we're playing, right? And then your different starting values, the lowest you can be is 4, right? Because lower than that, you'd have an ace, so you're going to be higher than that already. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that's 18 different possible starting values, right? From 4 to 21. So if we divide that by 18, that means on average, and again, this isn't perfect because we know there's more 10s in the deck, but on average, about 5,000 or so hands per starting value. Just an average here. Again, it's not exact, and that's okay. We're not doing the real math. But so of those 5,000, then about half the time, because we're using random numbers, it's not going to be exactly half you'll hit. About half the time you'll stand. So what we're going to output is, hey, here was the total number, essentially, of times that this was my starting hand value, and this is what happened when I hit. This is what happened when I stood. Right? Some sort of result here. So that we can kind of compare that then and see how it's going. Now, each of this, then the dealer can have 10 different cards showing, not even 10, right? So 2, 3, 4, or ace 2, 3, 4, 5, 6, 7, 8, 9, 10. Really just those 10. I guess like jacks, kings, queens, they all count as 10 essentially. So if we wanted to do like the crosstab table, like the Wikipedia shows us, hey, if the dealer has a 7 showing and we get a 4, this is what we should do, this is what we should do. We'll get about 500 of each of those or so. Still enough to say, okay, 250 hits, 250 stands. So the simulation should run pretty quick. It shouldn't take multiple minutes. Depending on how fast your computer is. If it's a really slow computer, it might take a minute or two. Don't run it 100,000 times every time if it's running really slow, right? Like, do it like 1,000 times to start, and if it only happens 2 to each hand, like, that's okay for now, and then you can crank it up as you go. So, like, if it's running really slow, don't sit waiting every time. We can adjust that later, but when you present, you'll play it, you'll show the simulation, show your results. Everyone should be pretty similar in result wise. If it's way off, then there's something obviously wrong with our program. But that's the kind of fun thing to debug there. And then maybe we'll look at your code and talk about it for a minute. So like 5-minute presentations or so. Rarely had anyone go up to 10 minutes. At 10 minutes, everyone's bored anyway, and we tell you just to go sit down. So ideally, low stakes presentation. Right? You should know how it went going into the presentation. So it's just a chance to chat amongst your peers. I'm sitting there evaluating it. I apologize. Like, I can't not do that, but I wanted to just be a friendly thing. And you'll do this a lot in the industry where you'll work on something and then you'll show it to your team. Say, hey, look, this is the thing I built. Let me show you what it does. So that's sort of that vibe for presenting. Man, I can't. It's Monday. I can't even talk. It's rough today. And we'll go from there, okay? So that's looking to the end of the semester here then. So we really only have a couple more meetings and then final project presentations. And then we are out of here. Hopefully you registered for winter. You have winter plans already. Very cool. All right. So let's talk about inheritance. So we talked about classes, right? This is one of the foundations of object-oriented programming, is being able to work with classes. The next step of that is inheritance. And what inheritance does is it lets us create this is-a relationship here. So we're familiar with this kind of idea, inheritance. Do I add the week numbers? I can never remember. I think I add week numbers, don't I? This is week 14. So how many of you folks are familiar with biology? You take biology in high school, learn about, was it kingdom, phylum, class, order, family, genus, species? I don't know why that's in my head still, but that is one of the things that's stuck for some reason, right? So like you have a kingdom classification and then the phylum and all the way down. So that's sort of what inheritance does for us here. It creates an is-a relationship, right? So all humans are mammals. All cats are mammals. It's an is-a, right? A cat is a mammal. A human is a mammal. So mammal is this broad, higher level, the parent, the super classification. And it has certain characteristics that all mammals share. And then the special versions of mammal, species, or I don't know, whatever level mammalia is. Instead of class mammalia? It's not kingdom. I don't know, whatever it is, that doesn't matter, right? We have new things that make us special versions of that mammal, right? So humans have certain characteristics that cats don't have, or cats have characteristics that humans don't have, but we share the mammal piece, all the mammal characteristics we share. So what we do with programming is we have that same idea. We can create this inheritance relationship. This is a relationship here. So I can write a class like, we'll have book here, and we'll define our init method. And then book might have, we'll take a couple pieces of information here. Let's take how about an author and the title and a publisher, right? So the self-author is the author, self-title is the title, and the self-publisher is the publisher, right? So all books will have these pieces of information here. Publisher, oh, just doesn't like the new lines. So I can talk about a book, right? But then there are special types of books here that are still books. They still have authors, they still have titles, they still have publishers, but picture books in particular, right, are a type of book here that's a special type of book. It needs to go down below here, sorry. So we can make a picture book class here. Now, to show inheritance in Python, to say I am a book, we put a set of parentheses and put the super class here. So there's all sorts of terms for this. So book is the super class, book is the base class, book is the parent class. Right? Picture book is the child class to the parent book class. Picture book is the derived class from the base class book. Picture book is the subclass of the superclass book. I don't know why there's so many terms. It's okay. And they're all used interchangeably here. I do like super and sub because we actually get a keyword for super. So there's a special operator, special word in Python for super. That means your superclass. So I like superclass and subclass. But again, they all mean the same thing here. So if picture book is a book, then when I have an init method, what has to happen first here is I have to call this init method here because I am a book. So we have to call the book init method. So to do that, we need to know the author, the title, and the publisher. So we need author, title, and publisher here as pieces of information to make a picture book. But then what makes a picture book special is we also have an illustrator, right? So we need to create a book given this information here. So we're going to call super here, and we're going to give it author, title, and publisher. And then we can say this illustrator, I don't want to type that again, is my illustrator. Oh, I'm sorry, self. So we're going to call my superclass and say, hey, go run your init method here. Here's your author, here's your title, here's your publisher. Then we'll set the illustrator to the illustrator. So a picture book is a book. What it lets me do is not reinvent the wheel. If I have a class that does all of these other really cool things, and imagine we had all sorts of cool functions we had in book. I don't know what cool things we'd have, but we can have cool things in book, right? But then I really wanted to have a picture book in my code somewhere. I don't want to have to redo all the things for book already, because I already have book, right? It lets me reduce the amount of code I have to write again, which is always nice. And then we'll get to a little bit more, some other cool things that it does here. But how about we just say, like, we add a method for, what do we want here? Get display string or something. I guess we don't essentially want to override the string function here, but this is okay for now. We can return self.title plus written by self.author and published by self.publisher. For some reason, publishers really want their credit here. I feel like they don't actually do much in the book industry. I've never done any publishing work before, so I don't actually know what's involved, but I feel like they get way too much credit when the author does all the work. So I don't know. Does anyone, have you ever worked with books? Like, why are publishers so crazy about that? Like, do you care who a publisher is? Like, have you ever been like, oh, I really want to read books by this publisher rather than by this author? Like, I don't get it. I don't know. I don't. Okay. I just know Pearson is an awful publisher, and they're the devil. So they're getting sued, though. I haven't heard how the lawsuit was going, so we'll see. We'll see. All right. So what we can do then to return our get display string, if we create a picture book that is a book, all of the things that book does, picture book can do. One of those things is get display string. So if I want to make a picture book, I don't know what is Fox in Socks is one of my favorite ones here. Sorry, so Fox in Socks equals a picture book. So the author is Dr. Seuss. The title is Fox in Socks. And the publisher, I don't even know who published it. Publisher here. And then the illustrator, I don't actually know who illustrated it either. Now I feel bad. Probably wasn't Dr. Seuss. It's like my favorite book, and I don't know. But that's okay. So now I have Fox and Socks. So I can say Fox and Socks dot, and I can have access to the attributes, right? We didn't bother making them private. I was being lazy, sorry. But you also see I get display string. And now PyCharm is being very helpful in saying, hey, look, this one comes from book. This illustrator comes from picture book. This publisher comes from book. This author comes from book. I'm not watching chat here. I'm sorry, folks. And this title comes from book. So you can see where the different attributes are coming from. Did I miss anything? Okay, good. I didn't miss anything. And I can get my display string, right, if I want, and I could just, print that. Sure. Get my display string. But now I'm not going to get that illustrator name when I print my display string. Oops. Oh, goodness. Nope, I did a bad thing here. Super init. There we go. Init. Sorry. Tell it that it's using the init method. No? Oh, goodness. Self. No? Oh, goodness. I did it wrong. This is what I get for not copy pasting. Requires a super object versus string. All right, we're just going to go look it up here because I don't remember. It's been one of those days. Oh, yeah. Okay, sorry. Not the super keyword here. The book dot init. That's obnoxious. I'm sorry. We'll use super in just a minute. I got too excited. So we tell it, hey, I want the book class init method here. I'm going to give you self as myself, the author, the title, and the publisher. It'll call this book init here. That ought to do it. Hey, all right. So Fox and Socks, written by Dr. Seuss, published by publisher. No mention of Illustrator. What we could do is we could write another method here for get display string. Now, here's where we're going to use that super keyword, because I could just copy paste all of this. I have access to these attributes because they're public. But what if these were private, right? If I said, hey, this is a private author, this is a private, I can't talk today, friends. This title, self-author, self-publisher. So if those were marked as private here, I can't take self dot and get those attributes. We're not allowed to touch them. I mean, we could because Python lets us, but we shouldn't. They've been marked as private. So if I want to get all of that information here, what I can do is I can say I super dot super. Why is it not cooperating? Get display string. What? Self dot illustrator. Super parentheses. Turn. This is why I need to not copy paste, friends. Okay, super parentheses gets our super class. Then I can use my dot notation and use all my attributes and get my display string from here. So this gets the superclass version, does the superclass version, then adds in whatever I want here, right? Illustrated by so-and-so. So we should just make that a formatted string, shouldn't we? Let's just do that. That's even prettier. Illustrated by self-illustrator. Look at that. Yeah, this should be a formatted string too. Make this prettier. All that concatenation is annoying. Written by published by, we're getting there. So I can do all the things my parent class does, or I can do special versions of my parent class. Oh, end quote. All right, so now we can get the correct version here of my get display string, which is really cool. So with inheritance, it creates that is a relationship. You are a type of your parent class. So you get all of the attributes of your parent class and all of the functions of your parent class because you are one of those, right? All humans are warm-blooded because mammals are warm-blooded. right? All cats are warm-blooded because mammals are warm-blooded. Right? All books have an author, a title, and a publisher, but picture books also have an illustrator that books don't have. Right? Most books don't have an illustrator listed in their credits, but picture books do. That sort of thing. So it creates the is a relationship. So we give all the attributes and all the methods, all the functions of our parent class, and then what we get to do is we are a special version. Right? What makes picture books different? Well, we added illustrator. Again, not super interesting, but we can do other fun things as well. So another fun example here is something like an item. So item has a name and a price, and probably a quantity, right? Like how many of that item do you want to buy? Self.name is the name. Sorry, we should make these private. Name is the name. Self.price is the price. And self.quantity is the quantity. Right, and then we might have a get total cost. And now this one might actually be interesting because we can return the price times the quantity. Right, take my self.price, multiply by the self.quantity. Now I'm going to tell you the total cost. So if you want to buy a dozen bottles of Coke out of the vending machine, rather than going to Kroger or Meijer, you've made a mistake. Right? Buying them one at a time, it doesn't feel so bad. But you know, if we're going to go buy a dozen, let's go out to Meijer. Go do it there. Okay, so that's an item. So we have set up our store. We can do all sorts of cool things with item. We're good with item. But if we want to do something special now, because, oh, by the way, the state wants in on this exchange of money here, because the state wants to make money to pay for our shared services, they want to tax things. Not all items are taxable, though, thanks to our interesting tax laws, where we don't tax fresh food. Right? Prepared food is a different story, but fresh food's not taxed, right? And then all other items. But so some things then are taxable items. So all taxable items are items, right? They all have name, they all have price, they all have quantity here. But what makes them special is that they are taxed. So we're going to define our init method here. Now, if you're an item, you need a name, you need a quantity, and you need a price, or name, price, and quantity, right? Price and quantity here. But then we also want to know what about the taxable item? Do we want the tax rate, or do we want to just have it fixed? We could do either way, right? Maybe we pass the tax rate here. So that way, and at some point, maybe different items will be taxed differently. Who knows? The tax code, I feel like, never gets simpler. It only ever gets more complicated. But again, this is what it is. So we need to call item. So item.init, given the name, the price, and the quantity. Given self, name, price, and quantity. Bless you. And then my self.tax rate is the tax rate. And that should, again, probably be private here. Now we get total cost, right? Needs to account for the tax rate. So I'm going to return my super.get total cost times the tax rate. Now, the problem here, though, is that I don't really know what tax rate is at the moment, right? Some people, when you ask them what the tax in Michigan is, they'll say 6%. Some people, when you ask them to enter a value for the rate of tax, and they enter the value 6 because they mean 6%, and we don't treat that as a decimal place, we now have a 600% tax, right? That'd be really bad and really upset. No one wants to pay 600% tax, right? So probably want some sort of sanity checking in here. And this is, again, we could do that with our class, but we're going to leave that for later here. So please sanity check. If someone says the tax rate is 6%, are they going to enter 1.06? Probably not, because that's what I need here if this is the arithmetic I'm doing. So if they just enter 0.06 for a 6% tax rate, this math is wrong, right? So it would really be this times 1 plus the tax rate, assuming that they give me 0.06 for the tax rate and not 6 for the tax rate. Again, well, we would sanity check that above. Is that okay? We're not doing that right now? Do you want to see it? No. Okay. All right. Good. So we'll figure that out later. We'll be okay. So now I can get my total cost here for my taxable item. I still do all the cool things item does. Any other stuff we've figured out for item, and they probably have UPC codes, and we have a list of these things, and we have our store inventory, and we have all sorts of fun stuff, and whatever else we're doing with item. But now I can charge the tax rate here, because a taxable item is an item. right? Its superclass's item, it is the subclass. Its parent class's item, it is the child class. The base class's item, it is the derived class. And whatever terms you like here, they're all interchangeable. So what's interesting though is we have to call this init method if our parent class has an init method that needs parameters, that needs arguments here. If we write a class that doesn't need those, then we don't have to worry about it, right? Because we'll just call the no argument init method with no trouble at all. So if our class doesn't need a bunch of arguments, we don't have to worry about it. But if it does, then we need to call that because we have to make one of these things first. So if I don't have this line here, bad things are going to happen when I try to make taxable items. So this is, so Coke is taxable, right? Pretty sure we pay sales tax on Coke. I feel like we do. And bottle deposits, because we want to encourage people to recycle. Interesting. So we can make a taxable item. So it is Coke. I have one of them, or no, it was price and quantity. Was it like $2.50 or something in the vending machine? I have one of them, and the tax rate is 0.06. Sure. And then we can print get total cost, or Coke.get total cost, and see if that works for us. It says, uh-oh, taxable item object has no attribute price. Oops, where's my price? There's no attribute for price. We never called the init method here. So it's actually from line 10 here in item failing because there is no self price. So it didn't crash on us here, but if we don't call this init method, bad stuff is going to happen, right? Because we don't have those attributes. So definitely want those attributes here. So now if I run it, it should work here. And look at that. They wanted to charge me. I can't believe Michigan really wants 4 billionths of a penny here. How dare they? I guess it adds up with a billion transact. No, I'm just joking here. Sorry. Right. But it works. We get the correct version out here. Now, again, math is hard in computers because of those rounding errors. Floating point numbers are difficult. All right. So inheritance creates that is a relationship. Now, this is different than a has a relationship here. Right. So when we talked about the final project, we said blackjack, right? There are cards and you have a deck with cards. A deck is not a card. This is a common mistake because once I show people inheritance, they're like, oh, I can use this everywhere. You really don't use it everywhere. Only where you have a is a relationship, right? So you might have a class for deck here. Deck's not a card, but it might have, an init here. It might have cards as a list of cards here, and then we could append a card, ace of spades or something. Sure. And this we'd have a class for card, and then if we card had an init. I don't actually recommend you use strings here, but that's okay. Face and suit. So face, suit is the suit. Strings is not going to be your most efficient way here. You're welcome to do it, but you have lots of options here. Why does it not like cards? Oh, self.cards. Right. So self.cards. It's self. Okay. So deck has cards, right? Not is a card. Just as an illustration here, right? Inheritance works when it is a type of the parent class. People do some really fun stuff too. I've seen people say like a player is a card, or a player is a deck, or cards are players, or you can make stuff work with code. Doesn't always mean it's right when we're thinking about how we build our solutions here. Okay, so has a, not is a, and has a is fine. We've been doing this for a long time already, right? We make lists of all sorts of things, right? Our classes have had a or has a string all over the place. Our classes has a integers or floats all over the place. We've been doing this, but now a class can have another class. Sure, a class can be an attribute of another class, right? Or maybe we have a class for player, right? And we have an init method for player. I don't know, self name something. Sure, why not? And then we might have a class for game here. Game can have an init method that has self.player is player, right? Self.dealer is a dealer, right? You can have other classes, right? If we have a class for dealer, sure, right? Dealer init. I don't even know what we want for dealer right now. Self.hand, sure, why not? Sure. So we can have a player, we can have a dealer, we can have a deck, right? You know, the game can have all sorts of other classes if we want here. It's perfectly fine. That's just has a. So game is not a deck, game is not a player, player is not a game. This sort of, sorry, I'm ranting a little bit here about it, but does that make sense? The difference between those relationships? Okay. Trying to get rid of all those yellow lines, sorry. Stop. There, okay. Now we got rid of the yellow line. That's not how you spell Seuss? Really? They typo it? Oh, okay. It just doesn't know what Seuss is. Okay. I thought it knew Dr. Seuss and knew I did it wrong. It's not Seuss. All right. So when we write classes, one of the things that's tricky with software is like once we've written a class and we're using it lots of places, changing the class can be tricky. So you might think, oh, well, why don't I just add Illustrator to book? Well, you know, not all books have illustrators. So we'd have to have a bunch of like blank illustrators, which might not be the worst thing in the world. But then we have to change that everywhere else we're using book, right? If we need to take Illustrator as an argument or use it as a function somewhere to set an illustrator, everywhere else we use book has to change. So not only is it nice because it creates that is a relationship, we don't have to reinvent the wheel, but it's useful for creating special versions of classes that do special things. Right? Rather than having to change book and change everywhere else I've used book in my code, I just make a special version of book for picture book. And I can add picture book in wherever I want in my code to use this instead. So it helps with the making software a little bit more modifiable, right? A little easier to maintain. Because it turns out that software is really expensive to have people write. You know, in terms of paying someone to write the software, pretty expensive. Where the software developers are not the cheapest folks in the world when it comes to labor. So most organizations tend to exist because they make money. That's sort of how things work here. So if they need to make money, they need to use the software that you wrote to make the money, right? And the business people out in the world realize that paying someone to write software is basically a fixed cost once it's done, right? I pay you X amount of money, I have this piece of software. So the longer you can use this software, the more return on that investment you're getting, right? So I want to use this piece of software for a long time to get more and more and more return out of the money I put into paying someone to build it. And the problem is, every so often things change, right? Maybe our tax rate changes, or we're no longer taxing certain items here for good reasons. We've been changing our tax code here for at least Michigan sales tax changed recently for good reasons. But our software has to change. So if it's easily modifiable, we can pay someone to make a couple small tweaks to it rather than rewrite the whole thing from scratch, that sort of thing. But the goal is that we want to make sure we can come back and change it later easily. Right? So we want to make it easily maintainable, easily modifiable, make it read real nice. Again, because you're going to move on to bigger and better things after you write your first program, your second program, your third program. The advice I give to most people is that loyalty doesn't pay anymore. There's no such thing as like you're at a company for 30 years, you're going to get a good pension, they'll take care of you. No, like you're going to leave companies, work at different places, get experience, find someone else who's going to pay you more money and leave. Right, and that's just sort of what this generation does, and that's okay. It's more of a transactional relationship. Well, there's nothing wrong with that if everyone understands this is how it works, I think. So you want to make sure your code is readable by the next person, because you folks are all fine, but the person they hire to replace you is probably someone who's crazy and will come after you and hunt you down for writing terrible code. That's a bad joke, I'm sorry. But write the code so that it's readable for other people. Other people can maintain it, that sort of thing. So this is one of the tools we get in our toolkit. We'll spend a lot more time on inheritance next semester. But one of the things we're looking at real quick is how we can be a type of another class, right? We is a of our parent class, we is a of our super class, right? To create that relationship, because there are some libraries that are super useful and helpful where we use inheritance to do all those things. So we'll inherit from the class that's in one of these libraries. We're just going to go import somewhere. We can import something, and then we are a type of that class, and then we're going to specialize what we do with it when we get there. Does that make a little bit of sense? So it's hard. Let me go. Maybe it'll make more sense if we look at it here. Let's look at our graphics. I think we do it in here. So there's this library called tkinter that lets us write graphical user interfaces. To make a tkinter application, you inherit from the tkinter frame class, because tkinter frame already knows how to do all of these things to make itself a pretty little window like this. We don't have to reinvent any of that, but we're a special type of window because now we're going to go add stuff to it, right? So we look at what inheritance is so that this stuff makes sense later on down the road. So hopefully this maybe is a better example to look at why inheritance is cool, right? I can be a tkinter application. I can inherit from tkinter. I am a type of frame here, and now I can go and display myself. Oh, this is you can do super init. My goodness. Okay, I really thought you could. I knew we could. All right, now I'm unhappy. So we can do it this way, or we can say super. I was missing the parentheses. That's what it was. Init name, price, and quantity. I think either one of those works, right? Yeah. So super parentheses dot init or item dot init. Now, if you use super, you don't have to give it self for what it's worth, right? It just it knows, because super parentheses is getting this instances, the self super class. Either one will work here, and that should be fine. Has to happen first is. Man, I'm leaving terrible notes in here. I'm sorry. So either one of these versions is fine as we go here. All right, so we'll do a little bit of practice writing a class. We're going to do shapes because shapes are fun, right? Think back to geometry, right? All squares are rectangles, but not all rectangles are squares, right? If you think of how that works, and rectangles of a certain number of sides, squares of a certain number of sides, and all sorts of fun stuff here. Okay, so we'll take a look at that in lab. So we got the rest of class time here to work on the final project. Again, aiming for about 45 minutes each session for the next couple weeks, or this week and next week. I guess that's a couple weeks, right? A couple's two, so that's a couple weeks. That's fair. It's not bad English. So it's time to work on that. If you're working with a partner, I can set up the repository so you both have access. I think a couple people emailed me about that. I just need both your GitHub usernames, and I can set you up. If you want to work on it individually, that's cool too. Totally up to you. And then we'll go from there, okay? I'm not planning on doing any more quizzes. I don't think we even had one on files either. Did I add a quiz for files? I don't remember if I did or not. Nope. I stopped after the midterm because I forgot. But I wasn't planning on for these later ones anyway. So is that okay? All right. I think we'll be good with quizzes. Again, we're kind of coming back to these topics later. We're not going to do graphics in 200 or 2001. There's just not enough time with all the other things we have to cover. But plotting's really cool. So, but there's just so many things. Like, it'd be silly to have a quiz on that anyway. So, all right, awesome. We are essentially winding down now, which is fun. So, not too many more new things. Wrapping up, working on our final project, and we'll get to the end of the semester here and have some fun. All right, thanks, folks. I'll stop streaming, and we'll see you in lab time.